Hello and welcome. Today, we're diving into navigating print standards, industry versus custom. This is the fifth webinar in our six-part series, designed to help print and packaging professionals improve color accuracy. In this session, we'll explore the critical aspects of maintaining print consistency through various standards and measurements. We'll look at the importance of printing to standards for CMYK solids and overprints, as well as tints and gray balance, which are essential for achieving repeatable production and reducing rejects. While industry standards can often be utilized, there are instances where custom standards must be developed to address the specific limitations of print conditions. I'm Ed Hattenberger, Senior Color Scientist at X-Rite, and I'll be guiding you through today's discussion. If you have any questions along the way, feel free to submit them using the chat function. I'll answer as many as possible at the end, and if we don't get to yours, an X-Rite team member will follow up afterward. Let's dive in. Effective press control begins with a fundamental element, solid ink density. Driven by ink film thickness and affected by various press factors, it must be closely monitored to ensure consistency and quality throughout the print run. Let's take a look at these three images. Even though the solid ink densities are the same, the visual appearance doesn't match. So, what's going on? Well, if the ink color shifts or the tonal value increase, TVI, also known as dot gain, goes out of tolerance, simply checking density won't catch it. That means even when density measures right, the final print appearance can still be off. To get it spot on, you'll need to look at a few other key metrics, like ink color, TVI, and for the best visual match, gray balance. Let's discuss these metrics and the international standards that help guide the way. While density is useful for maintaining consistency during a production run, it does not tell us anything about the color of the ink. But when it comes to make-ready or troubleshooting color issues, you need to rely on LAB values. As you can see in these examples, the cyan, magenta, and yellow inks look noticeably different, something density alone can't fully explain. This often happens when the wrong inks are used, or if they've been contaminated, which can occur if the press isn't cleaned properly between color changes, or if wet ink transfers from the substrate back onto other printing units. Images are made up of tints, so tonal value increase, or TVI, has a major impact on how they appear. Even if the solid ink densities are spot on, that doesn't guarantee the final image will look right. Take the two images on the right. They have identical solid ink densities, but they look very different. That's because the TVI is different, and in this case, the color lives entirely in the tints. TVI can be affected by lots of things: pressure, ink tack, substrate properties, and other press variables. For example, on a flexo press, ink viscosity and plate conditions, like wear and hardness, play a big role. On offset presses, the ink-water balance is a critical factor. So, if we're going to target LAB values and TVI, where do those target numbers come from? There are a number of ISO standards that guide print production, especially in the press room. These include standards for inks, print quality, and viewing conditions. There are also additional ISO standards focused on data exchange, PDFs, and pre-press workflows. When it comes to press room color targets for 4-color process, ISO 12647 and ISO 15339 are the key standards to know. ISO 20654 is a newer standard that helps us measure and understand spot color tint values. ISO standards are developed with contributions from regional groups around the world. Those groups then incorporate the new standards into their own specifications and methods. ISO 12647 is a long-standing standard for print process control. It defines target values for technologies like offset, newsprint, gravure, screen, and flexo, helping printers achieve consistent, accurate color. There aren't fixed ink density targets in these standards. Instead, they use LAB values for paper, solid inks, and overprints, along with TVI curves that are customized for different print conditions, and these are used around the world. In North America, Grackle and swap are the most common print conditions. They use the same solid and overprint targets, but rely on G7 near-neutral calibration instead of the standard TVI curves. The result? They usually match the official specs while giving you better gray balance. Of course, all of this depends on using paper that meets the right standard. In many real-world scenarios, especially in packaging, standard print conditions just don't apply. That's why printers often run custom print tests, followed by calibration and fingerprinting on press to reflect those unique conditions. From there, a custom ICC profile is created and handed off to the pre-press team. This profile becomes the foundation for accurate color separations and inkjet-proof simulations. But managing all these profiles can be tricky. For pre-media teams, juggling multiple custom profiles across different suppliers adds complexity. And for suppliers, keeping track of each pre-media partner's unique print targets can be just as challenging. If a job moves to a different press, or if you swap out key consumables like inks, substrates, or plates, things can quickly get messy. In the worst-case scenario, you may need to run a brand new fingerprint and even go back to the beginning to re-separate the files. That means more time, more cost, and more room for error. To help simplify the mess of custom press profiles, ISO 15339 was created. The idea is straightforward. Instead of building a new profile for every press condition, printers can choose from 7 standardized press gamut profiles. They pick the one that best matches their solids and overprints, then calibrate their plate curves to get near-neutral gray balance and proper tone values on their specific substrate. These 7 gamuts aren't just theoretical, they're based on what real CMYK presses can actually do. Across all 7, the CMYK aim points share a consistent hue angle, which helps maintain predictable, repeatable color. ISO 15339 is divided into 2 parts. Part 1 explains how to implement the process. Part 2 defines the target values you'll need to follow. The first step is to determine the largest, repeatable, and stable gamut of solids and overprints the press can achieve. Then, choose the Characterized Reference Print Condition, CRPC, that closely matches it. This might be a bit smaller than the press's full potential, but it will be a reliable and achievable standard. During the G7 calibration, the actual substrate color is used to calculate small adjustments to the target solid and overprint values, accounting for differences between the actual substrate and the standard. The plates are then calibrated for near-neutral gray balance and tone for that specific press and CRPC. After that, pre-press can use the standard CRPC ICC profile for color separation and proofing, and usually, there's no need for a custom ICC profile. Plus, if there are any changes, like shifts in the press conditions or materials, the files remain the same. Just recalibrate the plates for the new press conditions or materials. These are the Characterized Reference Print Conditions, or CRPCs. They're built on key target values from ISO 12647, which defines standardized print conditions for different types of printing. You might recognize Grackle 2013 and Swap 2013. These are updated versions of the 2006 standards, though the changes are extremely subtle and likely unnoticeable to the eye. Now, if your substrate color differs too much from the selected CRPC, specifically by more than 3 delta E, software steps in to help. It calculates what's known as substrate-corrected color aims. These are slightly adjusted CMYK and overprint values that account for how the color of the paper influences the final printed result. Gray balance target values are calculated to minimize the impact of paper color, from the highlights all the way to the shadows. In this example, we're working with a paper that has a LAB value of 95, 2, and -5. As we move across the tonal range, you'll notice that the A and B values shift closer to neutral. Starting from the paper's color values of 2 and -5, they gradually decrease. By the time we reach the three-quarter tone area, those values drop to about 0.5 and -1.25. This shows that the middle gray, located right at the midpoint, only keeps half of the original A and B values from the paper, reducing the paper's color influence by half. This illustration shows a theoretical perfect example of the near-neutral compensation. In reality, the darkest areas of these graphs for the actual calibration may not be perfect, but visually, the results are still acceptable. Plates are calibrated to achieve the gray balance targets values when running to that CRPC solid ink LAB values that are included. The purpose of these CRPCs is to ensure that when the same image is printed across each of the 7 conditions, it maintains a consistent color appearance. These images show how a file will print when properly separated and printed to each of the 7 different press conditions. The far left represents a press using the gamut of newsprint. The 5th and 6th images from the left are swap and grackle, which have much larger gamuts than newsprint. However, when calibrated to G7 near neutral, they produce a similar visual appearance, but with more vibrant and saturated colors. While the saturation and lightness might shift slightly depending on the print process, the hue of the color remains as consistent as possible. This approach is especially useful when creating different types of packaging for a single product, like labels, folding cartons, and shrink sleeves. A slight variation in brightness or intensity is fine, as long as the overall color hue stays consistent across all formats. Let's do a quick recap of the press optimization and fingerprinting process. It all starts with a test run of the press to stabilize your solid ink values. The goal is to get those values within tolerance of the largest CRPC your press can hit. You'll be using substrate-corrected color aim values, which means if your paper is more than 3 delta E away from the standard, you'll need to perform a G7 near-neutral calibration. That calibration is based on the specific LAB values of your substrate. When it comes to pre-press, there's typically no need to create a custom ICC profile. Separations can be made using standard CRPC profiles, or adjusted ones that include SCCA values if needed. Your proofing system can then use the same ICC profile to simulate the press condition. Only in rare cases, where the job is extremely color critical, would pre-press consider building a custom profile. But even then, the printer still aims to hit the CRPC target. So the next question is, how do you choose which standard, like ISO or CRPC, to use? If you're working with a substrate color that is close to a standard, ISO 12647 is a solid choice, and in that case, using G7 calibration is optional but recommended. But if you need to match color across different types of printing conditions, ISO 15339 is the better option. It requires G7 near-neutral calibration and relies on just 7 CRPCs that adapt to the substrate with SCCA as part of the process. This makes it easier to manage because you're working with a simplified, consistent set of targets rather than dozens of custom ones. In fact, custom targets are becoming less common. They still have their place for unique or highly specific applications, but they also take a lot more effort to create and manage, especially across multiple suppliers. The X-Rite Exact 2 comes preloaded with over 70 of the most widely used print standards from around the world. These standards are integrated into the job tool, which features an intuitive touchscreen interface and automatic patch recognition of substrate, solids, overprints, TVI, and gray balance. This functionality enables quick and accurate measurement of color bars and provides real-time, actionable feedback, allowing press operators to make fast, informed adjustments to maintain color consistency and reduce waste. X-Rite's Measure Color and ColorCert Pressroom Tools software provide comprehensive support for measurement of solids, overprints, TVI, and gray balance. These features are clearly displayed with visual indicators that highlight values in compliance and those that require operator attention, as shown in this Measure Color dashboard. For trained quality experts, the Measure Color NPDC tab provides additional data on the G7 neutral print density curves for black and CMY gray balance, as well as the weighted delta L and weighted delta CH for each metric. Package design frequently relies on tints and vignettes of spot color inks, where precise tone reproduction is essential for maintaining brand consistency and visual appeal. However, the traditional method for measuring tone value increase, TVI, based on optical density and defined by the Murray-Davis formula, falls short in these scenarios. Although it performs reliably with process colors, CMYK, this density-based approach proves unpredictable and inconsistent when applied to spot colors, often leading to unexpected print results and unreliable workarounds. These limitations highlighted the need for alternative TVI models that can account for the spectral and physical characteristics of spot colorants. ISO 20654 is the global standard that introduces the spot color tone value, SCTV model. Unlike traditional methods, SCTV uses colorimetric data rather than density to calculate tone values. This approach more accurately reflects how spot colors visually reproduce across various tint levels and is inherently more intuitive for designers and press operators. A key advantage of SCTV is its ability to produce a linear tone reproduction curve. A 50% tint both looks and measures like a 50% tone value. This one-to-one relationship simplifies quality control, making it easier to predict, evaluate, and manage tonal transitions throughout the production process. Older instruments and software may not support SCTV. X-Rite's ColorCert, Measure Color, and Exact2 solutions all make it easy to measure spot color tints using SCTV, ensuring consistent and accurate color across your print jobs. Okay, that is the end of today's presentation. Now, let's take a moment to go over the questions submitted during the webinar. If you haven't asked a question yet, please feel free to submit it through the chat. I'll answer as many as I can, but if we don't get to yours today, one of our X-Rite color experts will follow up with you directly. Also, if you'd like to discuss your specific color evaluation needs, a survey will pop up right after the webinar ends. To kick things off, let's take a look at the first question. You mentioned that we need to calibrate our press plate curves for gray balance to conform to G7. What tools do we need to do that? That is an excellent place to start. There are several third-party software tools that you can use. Some pre-press workflows and RIPs even include the calibration tools. You can find a list of what ID Alliance calls G7 certified systems on their website. Most of these systems support the X-Rite i1 family of instruments, including the i1 Pro 3, i1 ISIS 2, and the i1IO automated scanning table for chart reading. The automated chart readers are recommended for their speed and ease of use. Next question. Is there such a thing as ISO or GRACL compliant inks? The short answer is no. There's no such thing as ISO compliant inks in the strictest sense. Let me explain. ISO 12647 does not include a certification process for inks themselves. However, many ink manufacturers do formulate inks specifically to help printers meet ISO and GRACL standards, particularly by targeting the solid ink color values defined in ISO 12647 Part 2. Flexo inks often attempt to match the hue angle, but may have lower chroma. If your current inks don't align closely with the CMYK values of your chosen reference print condition, such as GRACL, it's a good idea to talk to your ink supplier. They may offer alternative inks that match better, while still meeting your other print requirements. I will take a couple more questions. Someone asked, my customer wants me to hit GRACL, but I'm printing wide web flexible packaging, not offset on paper. What should I tell them? This is a common situation. GRACL, CRPC6, is based on offset printing on coated paper, so it may not be realistic for wide web flexo on flexible packaging. This is where ISO 15339 and the Characterized Reference Print Conditions (CRPC) system come in. ISO 15339 defines the set of 7 CRPCs, each representing different print conditions with varying gamuts. You should start by working with your ink supplier to choose inks that offer the best color performance for your specific packaging materials. Then, perform print tests to determine which CRPC your process can reliably hit, for example, CRPC 5 for higher gamut systems, or CRPC 3 for lower gamut substrates. Once you've identified the closest matching CRPC, you can show your customer how your system aligns with an industry standard reference that's more realistic for your process than Grackhole. All right, this is the last question I'll get to today. I have an exact 2, and my operators like using the G7 job function and patch recognition. I'd like to review their measurements from the production run to see how well they're staying on color. How can I access that data? The exact 2 is an excellent tool for providing real-time guidance to press operators. However, if you want to review measurement data after the press run, you'll need additional software such as ColorCert or Measure Color. Both solutions allow you to view measurement data collected during the run, according to your specified sampling frequency. Measure Color, in particular, offers powerful tools for evaluating compliance with G7 print metrics. It also provides detailed graphs and diagnostics to help identify when and where gray balance or tonal value curves may have drifted out of tolerance. Okay, that is it for today. For those questions I didn't get to, an X-Rite color expert will be in touch soon. Thanks again for everyone's time, and please stay on for a quick survey. Have a great day,